Parallel universes are a great storytelling device, allowing us to see interesting versions of our favorite characters. They're also at the core of the Arrowverse, the shared universe of DC-based superheroes currently airing on the CW. While the main characters occasionally come together for epic crossover event, most of their individual escapades happen on Earths located in different parallel dimensions. For example, while Team Flash lives on Earth 1, Team Supergirl resides on Earth 38. So where do all these other universes come from? Are they just an excuse for cool storytelling, or is there some fact to go with this science fiction? Spoiler alert, the answer is a little bit of both. Parallel universes are more generally considered to be part of a multiverse, a larger space comprising an unknown number of distinct universes. Although we're all familiar with this idea from movies and video games, there's a scientific rationale to support it. To understand the origin of a multiverse, we must first step back to consider the origins of our own universe. Scientific models suggest the very early universe was infinitesimally small, then expanded very rapidly. Most cosmologists refer to this as cosmic inflation. But why did the universe suddenly expand? What caused this period of inflation? Most models point to the existence of a special particle called the inflaton. Like everything in the universe, this particle wants to be in its minimum energy state, and it achieves this by rolling down the slope of a potential energy well, until it eventually reaches the bottom and stops. As the inflaton rolls down the slope, its motion actually drives the rapid expansion of the universe. When the inflaton reaches the bottom of the potential energy well and stops, so does the rapid expansion. So far so good. But what does this have to do with multiverses? It turns out the inflaton doesn't always roll down the slope. Unlike a ball rolling downhill, which only travels in one direction, quantum fluctuations of the inflaton can force it to jump back up the energy slope. And because the particle never settles down at the bottom of the energy well, their universe essentially expands forever. But the interesting thing is that every inflaton jump creates a new bubble of space-time which is separate from the other bubbles. Each bubble is essentially its own separate universe where the fundamental constants of nature can take different values. This means the physics in each universe is likely to be different, and will evolve in a different way to our own. This theory is referred to as eternal chaotic inflation. Our best experimental evidence to support this model comes from the WMAP probe, a satellite experiment designed to measure tiny fluctuations left over from the Big Bang. The data provides experimental bounds on the shape and size of the inflaton potential well, but unfortunately doesn't tell us anything about these other universes. If they exist, they're undetectable for now. Video of Before the Big Bang for Eternal Inflation. The multiverse, a related, but separate, proposal for the origin of the multiverse arises from string theory, a proposed theory of everything. In this model, particles and forces are described as different vibrational moods, or notes of strings of energy. A key consequence of this theory is that the universe actually has 9 spatial dimensions rather than the 3 we experience in our daily lives. So where are these 6 extra dimensions, and why don't we experience them? Many theorists believe these extra dimensions are extremely small and wrapped around special higher dimensional objects called Calabi-Yau manifolds. The physics of the universe is then determined by the geometry of these objects. But as the number of these objects is large, this means the number of different possible universes is also large, and each would have slightly different physics. Initial estimates suggest there could be as many as 10,500 different universes, and while not each of them could support life as we understand it, there are many that could. Physicists call this the string landscape. So, which universe does ours correspond to? Unfortunately, finding a way to experimentally test this theory has proven to be very difficult, requiring new detectors that are currently far beyond anything we could possibly create. Even then, it may turn out that these universes are completely isolated from one another, therefore preventing us from being able to travel between them. Although the chances of you running into a version of yourself from another universe are pretty slim, science suggests it's not impossible. And who knows, in the future traveling between universes may be as easy as traveling to the store.